All right, college algebra folks, what I'm going to do right now is I'm going to go over test 1 that you guys took recently, and I want you to understand why you got certain questions wrong if you got them wrong. Okay, we're just going to go one question at a time. Question number 1 says to simplify x to the 4th times x to the 7th, right? Well, we're multiplying two exponential terms with a common base, right? Which means we add the exponents. So 7 plus 4 is 11. So this is just x to the 11th power. Okay? If you were to have another one, let's say that you had y times y to the 5th power. Well, we would just add the exponents. As long as we're multiplying a common base, 1 plus 5 is 6. This would be equal to y to the 6th power. All right, question number 2. Question number 2 is a little different than it's similar but different. It says we had x to the 5th power to the 3rd power, and we're simplifying. And what's happening here is that we have 3x to the 5ths, all multiplied by each other. So if we were to simplify this, we should multiply this together, and it would be x to the 15th power. And the reason is because we have x to the 5th times x to the 5th times x to the 5th. And for the same reason up here, if we multiplied it out like this, we would do 5 plus 5 plus 5, which is 15. So what if we had u to the 7th power to the 5th power? Well, this means 5u to the 7ths. That's 5 of them. That's u to the 7, 5 times over. U to the 7 times 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 u to the 7. So you do 7 times 5 is u to the 35th power. Okay? All right, question number 3. It said, what is x to the 8th power over x to the 5th power? Well, if it's a common base, when you multiplied a common base, you added the exponents. When you divide a common base, you subtract the exponents. And 8 minus 5 is 3. So this is x to the 3rd power. Okay? All right, let's move on to questions 4 through 6. All right, question 4 says x to the 3rd power times x to the negative 3 power. Now, simplify means reduce to its simplest form, including if that form is a number. So if you can reduce this to a number, which you can, just like question number 1, we would add the exponents, right? So multiplying a common base, so we're going to add 3 plus negative 3. Well, 3 plus negative 3, that's 0. So this is x to the 0 power. But we're not done, because what is anything to the 0 power? Except for 0. Anything to the 0 power equals 1. And so you should have written that the answer to this is 1. If you stopped at x to the 0, I gave you like half points because you're halfway done. X to the 0 is equal to 1. Y to the 0 equals 1. 5 to the 0 equals 1. 1.37 to the 0 power equals 1. Anything to the 0 power equals 1. Okay, all right. Moving on, question number 5. 5 says, simplify 7y to the negative 3 power. Well, first notice that negative 3 is not on the 7. And you're not going to multiply this negative 3 times the 7. That negative 3 doesn't have anything to do with this 7 at all. That negative 3 is the exponent on the y. And negative exponents mean it is a fraction. It belongs in the denominator. Okay, just like if I had a to the negative 5 power, that would be the same thing as 1 over a to the 5th power. Now this 7 does not have a negative exponent on it at all, so it doesn't go in the denominator. Only the y to the 3rd power goes in the denominator, and we'll put the 7 on top. And so the correct answer here would be 7 over y to the 3rd power. If I had one that said 3x to the negative 8 power, the answer to this would be 3 over x to the 8th power. Okay? All right, moving on to question number 6. Number 6 says 16 to the 3 over 2 power. Now, fractional exponents mean radicals. So if I had x to the 3 over 2 power, that would be the same thing as the second root of x to the third power. So the square root, basically. So what this is saying is the square root, the over 2 means the square root of, and the 3 on the top means to the third power. So third power, second root. Third power, square root. Well, what is the square root of 16? The square root of 16 is 4. So this is the same thing as 4 to the third power. Square root of 16 to the third power. 4 to the third power, that's 64. Now, some of you wrote 4 to the 3 over 2 power, or not 3 over 2, excuse me. Some of you wrote 4 to the third power, okay, and some of you wrote the square root of 16 to the third power. And I gave you partial credit for this, but this can be turned into an answer. The square root of 16 is 4, 4 to the third power is 64. And so the correct answer to this question is 64. All right, moving on to question 7. Question 7 says expand. And it says x squared times y to the 5th power. Okay? All right. Actually, I guess I probably should have just said simplify here. There was misunderstanding here, and I believe that I'm part of the reason for the misunderstanding here. But really, all I wanted you to do here is the same thing back when you did x to the 5th to the third power. I guess I could have called this expand also. That this was x to the 15th. I just wanted you to put the 5 on the 2 and the 5 on the y. And if you did that, 5 times 2 is x to the 10th power, and then it'd be y to the 5th power. Okay? Some of you did some other stuff, and I gave you credit for other stuff, but all I really wanted you to do here is just turn it into x to the 10th, y to the 5th. Okay? So that's number 7. Number 8, basically the same thing. We had x over, this is number 8, x over y to the 4th to the third power. I just wanted you to distribute the third power onto both of these. So this is x to the third power, and this is y to the 12th power. Okay? All right, because it's 3 times 4 is 12, 3 times 1 is 3. Right? Question number 9. Convert into polynomial form. We have 3 times the 5th root. That looks terrible. Hang on. 3 times the 5th root of x to the 4th power. Now the 3 isn't under the radical. The 3 doesn't have anything to do with the 5th root or the 4th power. So the 3 just stays as is. But this x to the 5th root of x to the 4th, remember, it becomes a fractional exponent. Power over root. So it's to the 4 over 5 power. Some of you put to the 5 over 4 power. So I know that you knew that it was something like that. But you got it wrong. The root here goes on the bottom. Remember, roots are in the ground. They're in the bottom, right? Power is up top. Power is high, right? So it's power over root. So it's 3x to the 4 over 5 power. Okay? If we had another one like that, let's say that I gave you 5 times the 3rd root of x to the 7th power. That would be 5x to the 7 over 3 power. Okay? All right. Number 10. Number 10 said x to the 6th y squared over x squared y to the 7th. Now what I asked you to do here is to put it in polynomial form. That means I don't want a fraction at all. So here we know that x to the 6th divided by x squared is x to the 4th power. That's easy. And you might have then thought, well then y to the 7th, or y squared over y to the 7th means y to the 5th in the denominator because the 7 is more powerful than the 2. Well, that's fine, but I didn't ask you to leave it in this form. I told you to leave it in polynomial form, which means this has to become y to the negative 5 power, and it has to be brought up. So the correct answer should have been x to the fourth times y to the negative fifth power. Another example, if I had a to the third power times b to the fourth power over a to the seventh power times b to the sixth power, in polynomial form, what we would do is we'd have a and then 3 minus 7 is negative 4 times b, 4 minus 6 is negative 2. And this would be our answer in polynomial form, not in rational form. Okay? It's 10. All right, moving on. 11 through 18 were all algebraic equations. Pretty much everybody got number 11 right. We have negative 3 equals 5 plus x. All right, this is just an algebraic equation. Subtract 5 from both sides, cancel, and we get x equals negative 8. Done. Okay. Question number 12. And they started to go downhill a little bit from there. Question number 12 says we've got 3y over 4 minus 1 is equal to 5. Now, what a lot of people did, there were two good ways to approach this. The first one is to cancel the denominator here by multiplying by 4. The other way is to add the 1 to the other side to make it a little bit easier before you cancel the denominator. Okay? But let me show you what a lot of people did. Many of the people who multiplied by 4 here, guess what they didn't do? Okay, they multiplied by 4 here, they multiplied by 4 here. So they canceled the denominator and got 3y, but they didn't distribute. They didn't multiply the 4 by the negative 1. You have to multiply the 4 by everything, not just the rational part. You see that minus there? That means you have to distribute, right? So 4 times negative 1 is negative 4. 5 times 4 is 20. Then we can add 4, and here's what they were doing. They had 3y here, they had 20 here, but they had minus 1 here. They did not distribute the 4. And therefore they added 1, and they got 21. Then when they divided by 3, they got y equals 7. But it's not y equals 7. This has to be a 4. Add 4, and we get 3y equals 24. Divide by 3, and we get y equals 8. Not 7. Okay? All right, let's go on to number 13. Question 13. 13 says 2 times x plus 3 is equal to 4x plus 5. Most people got this right, but there were some people who had a mix-up. Trying to remember where the mix-up came in, but basically they wound up with x equals 1 instead of x equals 1/2. We got to distribute the 2. 2 times x, 2 times 3, so we get 2x plus 6 equals 4x plus 5. Then we're going to subtract 2x here, subtract 2x here, and that gives us 2x. Subtract 5 here, subtract 5 here, and we get 1. Divide by 2, and we get x equals 1/2. Okay? You got to make sure, don't forget to distribute here. Don't just do 2x plus 3, it's 2x plus 6. You got to distribute that too. All right? Let's do question 14. Okay, 14 was interesting. We have x minus 8 over 2 plus 1 equals x minus 5 over 3. Now, there were all kinds of interesting problems with this one. I think everybody pretty much understood that they had to multiply by 2 to cancel this denominator and multiply by 3 to cancel this denominator. But there were people almost nobody, I mean, probably, maybe, I don't want to say it that way, maybe only a third of the people, when they multiplied here by 2 and multiplied here by 3, ever even multiplied this 1 by 2 or 3. We're distributing, folks. Anything, multiplication distributes over addition and subtraction. If you multiply this by 2, you have to multiply this by 2. And you have to multiply this by 2. Everything separated by an equal sign, a plus or a minus, has to separately be multiplied by whatever you're multiplying by. So we're going to do this slowly and one step at a time. We are going to multiply everything by 2. Here, it's going to cancel the denominator, okay, bringing down x minus 8. Here, it's going to multiply by positive 1, giving us positive 2, equals. Here, we cannot cancel the denominator with a 2, we need a 3. Therefore, instead of canceling the denominator, we're going to multiply through x minus 5. And we have to multiply through the whole thing. We got to distribute it to the x and to the minus 5. So 2 times x is 2x. 2 times negative 5 is negative 10, still over 3. Now, we can clean up a little bit. Do you see this x minus 8 plus 2? We can clean this up. Negative 8 plus 2 is negative 6. So we have x minus 6 over here. And then here we have 2x minus 10 over 3. Now we can cancel this denominator by multiplying by 3, but we got to multiply everything by 3. When we multiply this by 3, it's going to cancel the denominator, leaving us with 2x minus 10. When we multiply this by 3, it's going to be negative 18, and when we multiply this by 3, it's going to be 3x. We're really close. Now we're going to subtract 2x from both sides. Can't eliminate over here. 3x minus 2x is x. We're going to add 18 to both sides. Eliminate over here. Negative 10 plus 18 is positive 8, and we have x is equal to 8. Okay? I recommend that you go back and do this a few more times if you didn't understand. Watch my video again and again, just this part again and again and again and again until you get this, until you understand why this works. Okay? All right? Let's try question number 15. Honestly, I think that was the hardest one out of all of them, folks. It's just these others now are the inequalities, and sometimes you don't know what to do with an inequality. All right, so we've got 15. We've got negative 2x is greater than or equal to 10. Very simple, very straightforward, right? All we have to do here is divide by negative 2 on both sides. Very simple. Cancel, we have an x. 10 divided by negative 2 is negative 5. Hang on a second. There's a rule when dealing with inequalities algebraically that when you divide by a negative number, you have to flip the sign. You have to flip the inequality sign. So if this inequality sign has to flip around. So instead of x is greater than or equal to negative 5, it's x is less than or equal to negative 5. Okay? That's all we have for number 15. Right. Let's try number 16. All right, 16, we got 5 times x minus 3 is less than or equal to 2x plus 6. All right, well, this is just like kind of like question number 13. All right, we just got to distribute the 5. 5 times x is 5x. 5 times negative 3 is negative 15. Make sure you distribute, though. Don't only multiply the x. You got to multiply both of them. Is less than or equal to 2x plus 6. Now, we'll subtract 2x from both sides. Eliminate on this side. Subtract 2x. 5x minus 2x is 3x. Here we're going to add 15 to both sides. This side's going to eliminate. Add 15. And we get 21. Bring down the less than or equal to. Now here, we're going to divide by 3. We're not dividing by negative 3. We're just dividing by positive 3. So we're not going to switch any signs around. We're just dividing by 3. Dividing by 3, and we get x is less than or equal to 21 divided by 3 is 7. Most people didn't have problems with that question. All right, now let's try question number 17. 17 was tricky. Not tricky meaning it was a trick question. I mean, it was tricky. It's tricky in the sense that it has a good bit of work to be done. We got negative 8 is less than or equal to 1 minus 3 times x minus 2 is less than or equal, or sorry, is less than 13. It's less than 13. Now, I want to clean up the middle first before I do any funky algebra, okay? So I'm going to distribute this. Now, note, this is not just a 3. That negative sign belongs to that 3, so I'm distributing negative 3, not just 3. Negative 3 times x is negative 3x. And by the way, there's a 1 there. Negative 3 times negative 2 is positive 6. Okay? Less than 13. Over here, we got a negative 8 is less than or equal to. Now look at this. We've got a 1 plus 6. That's 7, right? So really, we have 7 minus 3x less than 13, negative 8 less than or equal to. So here's the thing. Because there's 1, 2, 3 parts, instead of thinking whatever I do to one side I'll do to the other side, it goes like this. Whatever you do to one of the parts, you have to do to all 3 of the parts. Okay, so I'm thinking I'm going to subtract 7 here, right? Well, if I subtract 7 here, I have to subtract 7 here, and I have to subtract 7 all the way over here. So I'm doing it in 3 places. Here it's going to eliminate. Negative 8 minus 7 is negative 15, less than or equal to negative 3x less than 13 minus 7, that's 6. You might say, hang on a second, Mr. Ryan. You just did negative 7 here. Why didn't you flip the sign around? Because I didn't divide by negative 7. Because I didn't multiply by negative 7. I subtracted 7. You don't flip the sign when you add and subtract. You flip the sign when you multiply and divide a negative value. All right, now I'm about to divide by a negative value. All right, so now here I'm going to divide by negative 3 to get x by itself. That means I'm going to divide here by negative 3, and I'm going to divide here by negative 3. Negative 15 divided by negative 3 is 5. And because I divided by a negative, I'm going to flip this sign around. Here I'm going to eliminate the negative 3, leaving an x. Here, negative 6 divided by negative 3 is negative 2, and because I divided by a negative value, I'm going to flip the sign around. And this is the final answer. X is greater than negative 2, but less than or equal to 5. Okay? And I want you to, well, actually, I'm going to leave it at that. All right, you can flip it around if you want. You could have written your answer as negative 2 is less than x is less than or equal to 5, and that would be even better. But this is fine. Okay? So that's question 17. All right, now let's look at question number 18. Question 18 is an absolute value inequality. We have the absolute value of x minus 12 is less than or equal to 4. And here's what I suspect. I suspect that some of you didn't view the video that I had sent out, and it's probably because you had a hard time accessing it. I don't know. But I mean, you could have done everything you had to do to get it. All right? You may not have watched the video that I sent out on solving absolute value inequalities. All right? But here's the thing you need to understand. The way you solve an absolute value inequality is, in fact, this is the way you solve an absolute value equation also, is you take the thing on the inside out of the absolute value and you set 2 of them up. So we've got an x minus 12, and the first one is set up exactly as you see it. X minus 12 is less than or equal to 4. But now you have to set up a second one, another x minus 12, only instead of using 4, you're going to flip the sign. You're going to make it negative 4. And then instead of making it less than or equal to, you're going to make it greater than or equal to. So this turns into 2 separate inequality equations. One with a positive 4, one with a negative 4. One with a less than or equal to, one with a greater than or equal to. And the basic idea is this, is if you flip the sign on the number, you have to flip the sign on the inequality. Because it's basically like dividing by negative 1 or multiplying by negative 1. And when you multiply or divide by a negative number, you have to flip the sign. Okay? So now we have 2 separate to solve here. Here we're going to add 12, add 12. Cancel. X is less than or equal to 16. Done. Over here, same thing. We're going to add 12, eliminate. X is greater than or equal to, oops, that's a 12. Negative 4 plus 12 is 8, so x is greater than or equal to 12. So our final answer, 2 answers. That's why on a lot of your papers I wrote half of the problem, or just half, is because you only did half of the problem. You only either did this one or you did this one. You did not do both of them. You have to do both of these, okay? So that's question number 18. All right, let's see here. All right, for question number 19, we're going to go over to this coordinate plane right here because it says, what is the equation of the function graph below? And this is what it shows you. Goes through here, 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 goes through here. Okay, it kind of looks like this. You got this graph. Looks like this. And you have to give me the equation of it. Well, the equation of a line, best way to put it is in y equals mx plus b form. So your answer should be y equals, well, what's the slope on this line? Well, start here at the y-intercept. You're going to go down 1, 2, and over 1. Down 2, that's negative 2, over 1. Negative 2 over 1 equals negative 2. This graph has a slope of negative 2. Then put an x. What's the y-intercept here? From the origin, 1, 2, 3, positive 3, plus 3, there's your answer, negative 2x plus 3. Guys, this is one, if you can't do this, if you can't read a graph, a line graph, and write the equation, you've got to spend a lot of time on this. You should spend a few hours on the internet going to websites and learning how to write the equation of a linear function. This is like 7th grade here or 8th grade. You've got to know how to do this. And if you don't know how to do this, please come see me. I will give you hordes and hordes and hordes of practice doing something like this. But you've got to know how to do the equation of a line. Have to know how to do it. All right, let's see here. Then the next question, number 20, says graph y equals x plus 3. All right, graph y equals x plus 3. Well, look what we have here. We have a y-intercept of 3. So y-intercept b equals 3. And we have a slope. What's in front of this x? There's a 1 there, so the slope is 1. So we're going to go to the y-axis, and we're going to go to positive 3 right here. Then we're going to do a slope of 1 through that point. Up 1 over 1. Up 1 over 1. Up 1 over 1. And so the line is going to look like this. There we go. There's the straight line. Y equals x plus 3. All right. Again, you got to know how to draw a line. We're going to be doing other stuff in this class, especially next semester in statistics, where you have to be able to draw a line. You have to be able to draw the equation of a line. You have to know the mx plus b form. Okay. All right. Let's see here. Moving on to write the equation of the line. This is question 21. Write the equation of the line that passes through 2, 1 and 4, 11, and write it in slope-intercept form and in point-slope form. Well, point-slope form is easier than slope-intercept form. In fact, if I can put it in point-slope form, I can then transform it into y-intercept form, or slope-intercept form. But I have to find the slope form first. Slope is equal to y2 minus y1 over x2 minus x1. So I need the two y values. There's a y value, there's a y value. And I need the two x values. Here's an x value, here's an x value. All right. I'm going to go over to the second one. See, this is a 2, this is a 4. The x is larger, that makes this my x2, and that makes this my y2. So y2 is 11, minus y1 is 1, over x2, 4, minus x1 is 2. 11 minus 1 is 10, 4 minus 2 is 2, and 10 divided by 2 is 5. And so the slope is 5. So here's what I'm going to do. Point slope form is y minus y1 equals m, the slope, times x minus x1. This is it. This is going to stay a y. This is going to stay an x. But I got to put a number here, a number here, and a number here. Now the number I put here is the slope, which we just found is 5. So I'm going to put a 5 here. The number I'm going to put here is y1, and it can be any y value. I'll just use these y values. This will be my x1, this will be my y1. And I know what you're thinking. You're like, but you just said that was x2 and y2. I've said this before. It doesn't matter which one is x1 and y1 as long as they come from the same coordinate. Okay, what I'm saying is you can put this y or this y in here. Well, let me just show you. I'm going to put 11 here. So I'm going to put y minus 11 because 11 is a y value. I'm going to put the slope here, 5, and then I'm going to put x minus the x value that goes along with this y value, which is 4. So I'm going to put a 4 there. That's one possible answer. The other possible answer is y minus, if you use this point instead, you could use that 1 right there. Y minus 1 equals, the slope is still 5. We still have an x here. We still have a minus, and we still have a 2. Well, x minus 2. Okay? So either one of these would be acceptable as point-slope form. Now here's the funny thing. We're going to turn this now into slope-intercept form, and it's going to be the same either way. The way you convert it into slope-intercept form is this. Distribute the slope, 5 times x, 5 times negative 4. That gives us 5x minus 20. And we've got y minus 11. Now add 11 to both sides. Eliminate, and we get y equals 5x. Negative 20 plus 11 is negative 9. And so in slope-intercept form, it's y equals 5x minus 9. You needed to give both of these. I said in point-slope form and in slope-intercept form. Okay? All right, that's question number 21. Now let's look at question number 22, which, by the way, is a lot easier than 21. All right, 22 says, write the equation, 22, sorry. It says, write the equation of the line that is parallel to y equals 3x plus 5 and passes through the point 5, 2. Parallel means same slope. So, same slope. So we know that this other line that passes through 5, 2 has a slope of 3. It has a slope of 3, passes through the point 5, 2, point slope form. Y minus 2 equals 3 times x minus 5. Done. There we go. We're good. We just put the slope here, we put the y value here, we put the x value here, and we're done. We don't even do anything else. We're done. That's the answer. Okay? So now, let's go to question number 23, which asks basically the same thing, except it says, write the equation of a line that is perpendicular to y equals negative 4x minus 7 and passes through the point 1, 6. Passes through the point 1, 6. Okay. Perpendicular means not the same slope. It means the opposite. So if your slope is negative, it becomes positive. If your slope is positive, it becomes negative. And the reciprocal, so you got to flip the fraction. So our slope here is negative 4. So the opposite of negative 4 is positive 4. And the reciprocal of positive 4 is 1/4. And so the slope we're looking for here is positive 1/4. And it passes through the point 1, 6. So in point slope form, that's y minus 6 equals 1/4 times x minus 1, point slope form. Now, if you're not getting this point slope form thing, you need to get on the internet and look up point slope form of a line and learn all about it and try to understand it, okay? Because it's really easy, and it's frustrating to me that someone might not understand essential knowledge that is easy to understand, okay? And if you can't get it online, you got to come to me, because we can go through this a million times if we have to, and you'll eventually get it and you'll know it, okay? All right, so that's 23. Let's go on to 24. 24, we're going to use a coordinate plane, and I'm going to use other color markers, I guess orange and green maybe. It says to use graph a system of linear equations to solve it. And we've got y equals negative 3x plus 5, and we've got y equals 2/3 x minus 6. Now, if you don't know how to write the equation of a line, you're sunk here. You can't do this. You have to know how to write the equation of a line. We're going to draw this one in green, and we're going to draw this one in orange. Okay? So this one, y-intercept of 5, slope of negative 3. Y-intercept of 5, slope of negative 3. That means it goes down 3 over 1, down 3 over 1, down 3 over 1. Okay? We grab a yardstick here, and I'm going to draw the line. All right. Looks pretty good. Oh, I missed the spot. There we go. That's close enough. All right, now, in orange, y-intercept of -6, slope of 2/3. 1, 2, 3, 4, 5, 6. That's -6. Up. Okay, slope of 2/3 means up to, rise over run. Up 2 over 3. Up 2 over 3. So up 2 over 3, that's right there. That's our solution, by the way. I mean, we just happened to hit our solution. Let's go ahead and draw the line anyway, because it's the right thing to do. There we go. And now we just got to look to see where do the two lines cross over. Well, they cross over at this point right here. That's x equals 3, y equals -4. And so the correct answer is x equals 3, y equals -4. We just solved a system of equations by graphing two lines. All right, let's try question number 25. Here we go. All right, question 25. We've got a couple left here. Question 25 says, solve the system of linear equations by substitution. And we have 12x equals 42 minus 2y. And the other equation is y plus 5x equals 17. Now, if I'm going to solve by substitution, I need to solve for one of these variables. I need to get x by itself or y by itself, either in this equation or that equation. I usually go for the one that's already almost by itself. And look, the y here is almost by itself. It already has a coefficient of 1. Here, for this x, I'd have to divide by 5. For this y, I'd have to divide by -2. For this x, I'd have to divide by 12. I don't have to divide by anything if I use this y. And to get this y by itself, I just have to subtract 5x from both sides here. So I now have y is equal to -5x plus 17. Now that I've solved for y, I need to go to the other equation, the 12x equation. And in for y, I got 12x equals 42 minus 2. Instead of putting a y here, I'm going to put -5x plus 17 because that's what y is equal to. I'm going to put in -5x plus 17. Now I'm going to solve like I solved question number 13. I'm going to distribute this -2 here and here. -2 times -5 is positive 10x. -2 times 17 is -34. I've still got a 42 here, and I still got a 12x here. Subtract 10x here, subtract 10x here, and I get 12x minus 10x is 2x equals 42 minus 34, that's 8. Divide by 2, x equals 4. But I'm not done yet. I've only got my answer for x. I still need to find out what the answer is for y. So I'm going to take the x equals 4. I'm going to go over here to the y equals -5x plus 17, and I'm going to put the 4 in. So I'm going to have y equals -5 times 4 plus 17. -5 times 4 is -20 plus 17. -20 plus 17 is -3. And so here's my answer. X equals 4, y equals -3. All right, question number, let's go to 26. Question 26 says, solve the system of linear equations by elimination. And I have 5x equals 5 minus 3y. And then I have y equals -2x plus 1. Okay? Now, here's what I need to do in this case. I need to line up my x's and my y's. I need to put them in what's called standard form. I got to have number, then x, plus number, then y, then equals, then c, then the number that doesn't have a variable on it. This one's close up here. Look, I've got 5x equals 5 minus 3y. Well, if I add 3y to both sides, that's going to move the 3y over, and now I'm going to have 5x plus 3y equals 5, because I canceled the 3y over here. On this one, the y is already in the right place. I need to move this negative 2x over here. So I need to add 2x here, add 2x here. That's going to cancel here, and I'm going to have 2x. This is already a positive y is equal to 1. Now, they're layered on top of each other. X's first, then the y's, then the equals, then the numbers. Now what I need to do is I need for either my x's or my y's to have the same number in front of them. But one of them has to be the same number positive, the other one has to be the same number negative. And the way that I can accomplish that, if it's not already, here's a 5. I would need a negative 5 here. Here's a 3. I would need a negative 3 here. Okay? And I can multiply both of them. Like up here, I can multiply this by 2, and that would give me 10x. And down here, if I multiply by negative 5, that'll give me negative 10x. And then they can cancel. But I feel like the easiest thing to do here is just multiply this whole equation by negative 3, because that'll put a negative 3 in front of this y, and then I'll have a 3y and a negative 3y. So I'm going to bring this over here. 5x plus 3y equals 5. No change at all. Here, negative, and I got to distribute here. Everything has to be multiplied by negative 3. Negative 3 times 2x is negative 6x. Negative 3 times y is negative 3y. Negative 3 times 1 is negative 3. Now that I have the same number, only opposite in front of one of the variables, in front of the y, now I can add the two equations. I'm going to add the x's, I'm going to add the y's, and I'm going to add the constants. 5x minus 6x is negative x. 3y minus 3y, well, those eliminate. They cancel. They become 0, so I don't need them anymore. Equals 5 minus 3 is 2. So I have negative x is equal to 2. Well, I don't want to know what negative x is equal to. I want to know what x is equal to. So I'm going to divide by negative 1 on both sides, or multiply by negative 1 on both sides. It's going to cancel the negative, and I get x equals negative 2. Well, now I know what x is, but I still need to know what y is. So I'm going to go up here to one of my original equations. Do you see this y equals negative 2x plus 1? Well, that's what I'm going to use, except instead of x, I'm going to put in what x is equal to, which is negative 2. Negative 2. So now y is equal to negative 2 times negative 2 is 4, plus 1 equals 5. So y is equal to 5. So our solution is x is equal to negative 2, y is equal to 5. Okay? Only 2 more questions left to go over on this test. Hopefully this is helping you. All right, so for question number 27, we're going to go over here to the coordinate plane. It says graph the linear inequality y is greater than 2x minus 5 and shade the solution region. Again, you have to know how to draw the equation of or draw the graph of a line. We've got a y-intercept of negative 5. 1, 2, 3, 4, 5. So that's negative 5. And we have a slope of positive 2. So here we're going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. We can also go down here. We can go back or down 2, back 1. That's negative 2 over negative 1, which is still positive 2. And now in this line, you can get a ruler or something, but you need to graph a dashed line because this is not or equal to. So if you graphed a solid line, that's why one of the reasons you got part of it wrong. You got to graph a dashed line here. So it's going to be that, 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 and that. There you go. There's your dashed line. y is greater than 2x minus 5. Now, we got to shade either above or below. And it says greater than. Greater than is above, right? So go to one of the points, go vertically up, put a dot, that's your solution region. And up here, you're going to shade. And then you're done. That's your solution to that one. One left, question number 28. Question 28 wants you to graph a system of linear inequalities, which is basically a system of linear equations with shading. Okay? So let's see here. We have y is less than negative x plus 6, and y is greater than or equal to 4/3 x minus 1. So let's draw this line. Negative x plus 6. Y-intercept of positive 6. 1, 2, 3, 4, 5, 6. Put a dot there. Slope is negative 1. Okay, because there's a negative 1 in front of this x. So negative 1, that's down 1, forward 1. Down 1, forward 1. So down 1, forward 1. Down 1, forward 1. Down 1, forward 1. So this is a slope of negative 1. And does it say or equal to? No, it's just less than, which means the line is going to be a dashed line, not a solid line. So dash, 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 dashed, dashed. It's a dashed line, okay? And it says y is less than. That means we want to shade below. Okay? So from here below, go vertically down, and it's down here. So we're shading this region here. Okay? Now let's do the other line. 4/3 x minus 1. Y-intercept of negative 1. So let's go down 1 to here, negative 1. Slope of 4 over 3. Positive 4 over positive 3. That means up 4 over 3. 1, 2, 3, 4, 1, 2, 3. There's our intersection point right there. 1, 2, 3, 4, 1, 2, 3. Right there. Is this going to be a dashed line or a solid line? Well, this says greater than or equal to, so it's a solid line. So let's grab this yardstick here. I think this yardstick might be a little bent. Nobody likes a bent yardstick. All right, we'll draw a solid line here. There we go. And it says greater than or equal to, that means above the line, vertically up. So if we go to the line and go vertically up, it's up here. Okay? So it's here. And now we're looking for where there's overlap. Well, this line was here, this line is here, and so here's the overlap, right? So this region in here is the solution. You could just write solution region in here if you want to, or you could shade it in real well. But you can see it runs along here and along here. Okay, but it's a dashed line. And there's your solution region. That's it for this test. I hope that this video has helped you go over the test so that you can understand what it is that you did wrong. Please come to me. I've got a review packet. You go over that. We've already talked about this in class. I'm going to let you retake the test, and then hopefully you'll understand this better. You'll do a lot better, and we'll all be happy. Okay? All right. Have a good day. I'll see you later.